Unit 8, this is our 8th unit. This unit introduces us to polynomials, and once you have the foldable together, there are going to be some vocabulary that we'll be talking about first. All right, so types of polynomials. So this will be the first part of your foldable. Okay, so this first type of polynomial is called a monomial. Okay, a monomial just simply means one term. So that's why you see the number 1 here. So you want to add that to your foldable. So one term could be like a constant, a 6. One term could be a variable, an x. It could be a variable and a number together. That's considered one term. So terms are separated by plus signs and minus signs. So this is considered also a monomial. Okay, this is one term. You don't see like plus 6 or plus 10 or plus 8x. It's just considered one term. So we call that a monomial. Okay, bi means 2, so that's 2 terms. So you'll see 2 terms here. You have x minus y, and again, the terms are separated by plus signs or minus signs. We have something like, and these are just examples, 7x squared minus 5x. Okay, all of those would be considered a binomial. Okay, you have 2 terms. So what do you think 3 terms are called? Trinomial, okay. So that's what we call a trinomial. And again, terms are separated by plus signs and minus signs. So this would be one term, the 9x squared. Here's your second term, the negative 5x, and the positive 2. All right. Now, if it's called a polynomial, because all of them are called polynomials, polynomials are means many. Okay, so we stop classifying after 3. So after we have the monomial, the binomial, the trinomial, we don't say anything else. We just call everything else after that a polynomial. Okay, but if it had just 1, 2, or 3, then it has a special name. Right, has a special name. So I could have stopped at the 4th term because, again, anything after the 3rd term, then you'll have a polynomial. All right. Now, these are non-examples, so things written like this, we don't call these polynomials. So those are some examples. All right, so now let's move on to some examples. And in your foldable, okay, here's the first example. Let's just start with the 7xy to the 3rd. Now we're going to talk about how you determine the degree. Okay, how do you determine the degrees? So I want to talk about, when it says degree, what these numbers represent. Okay, these numbers right here represent the highest exponent in the problem, okay, or in the term. So like here, the highest degree is 2. The highest exponent is 2. Here, the highest exponent between the 2 terms is also a 2. The highest degree here, and again, you're comparing all 4, is a 3. So you don't add them together, you just take the highest one you see. And the highest one here is also 3. So when it asks for the degree, it's asking for the largest exponent in the polynomial. Okay. Now, leading coefficient. Okay, what does that mean? The leading coefficient is like here, the first one you see. Leading means it's the first one in this case. Here, it will be a 7. Okay, for the degree of the 2, it's the leading coefficient is 5. For the exponent 3, the leading coefficient is -8. And for the exponent 3, the leading coefficient is -1. So the leading coefficient basically is the number in front of, or the coefficient to the degree that you just wrote down, okay? So you just look at that particular coefficient. All right, now, here this says constant, no. You guys know what a constant is. A constant is a number that does not have a variable. Okay, so in case you don't know, you might want to put a little notation. Okay, terms that do not have variables to them, that's what we call a constant. So those are just your regular numbers. This term does not have a constant, okay, because it has variables beside the 7. This term here, no constant. Each term has variables. This one does have a constant. The constant is -5, right there. This one has a constant. And again, this is all about vocabulary. The constant is 4. All right. So what I'm going to do is go back up to the top and just kind of emphasize again what type of polynomials we have here. This would be a monomial. This will be a binomial. This will be a polynomial. And this will be a trinomial. Okay. All right, so now what we're going to do, and this is something that you guys did last year, so this is really not new, is just combining like terms together. So if you are to add a binomial to a binomial, basically all you're doing is adding your x's together and adding your constants together. So if I have a -2x and a +1, that's going to give me a -1x. We don't write the 1. A -9 and a +5 is a -5. I mean, -9 and a +4 is a -5. So this is not new. This is just combining like terms. If you want, you could also rewrite it this way. Okay, so some people like the vertical method, and where you just simply put the like terms underneath one another and do it this way instead of going horizontally. That is totally up to you. If you want to rewrite it and put it vertically, especially when you have more than just 2 terms, it might be a good idea. Same thing here. You could take this -5x plus 17 and the -9x plus 4, and you could write it that way. Okay? So I want you to know that option is there. So that gives you a total of -14x plus 21. Okay. All right, moving on. Again, this is not new. And again, you can only combine like terms together. So what does that mean? Like terms means they have to have the same variable and exponent. So put a little note, same variable and exponent. So that's what it means when we say like terms. So if I wanted to rewrite this, I would rewrite it this way. I will put the 6x squared under here, the 3x here, and then I would just fill this in with a 0 since I don't have a constant for the last one. Okay, so when I combine these together, I have 9x squared, and a -2 and a +3 is a +1 plus 1. Okay. All right, so let's take a look at question 4. I'm going to rewrite it vertically. So 6x squared minus 12x plus 1 plus 8x squared plus 10x minus 6. So I'm adding x squares to x squares, x's to x's, constants to constants. So this will be 14x squared minus 2x minus 5. Okay, again, just adding like terms together. Now, sometimes you might have to distribute. Okay, we know the distributive property. So what you would do here is distribute the 5 to the first set of parentheses, distribute the 3 to the second set, and then combine your like terms together. So let's go ahead and distribute the 5, and of course the 5 has to be multiplied by each term. So 20x to the third minus 10x squared plus 5. Okay, so that's just multiplying everything inside by 5. Plus, now I'm going to multiply everything by 3. So 21x squared minus 15. And let me do this because I see I have a 15x here. So what I'm going to do, I'm going to fill this in since I don't have, let me move this over. I need to correct this. I need to move this x squared under the other x squared. So this will be 21x squared. And then I'm going to have minus 15x. And then I'm going to have minus 12. So really everything at the top, you can just fill in with zeros if you want, or you can leave it blank. Okay, it doesn't matter. Yes. 5 times 3. All right, so let's correct that. This actually should be a 5 from the very first one. Okay, right here. Okay, so now we can, go ahead and just add everything together. I'm just going to bring down this 20x to the third. And what's negative 10 plus 21? That's a positive what? Positive what? 11. And then this is minus the 15x, and this is minus 5. Minus 7, my fault. Minus 7. So again, all you're doing is just combining like terms together, but just make sure you didn't do the mistake like I did. Put that 21x squared under here. You want to make sure x squareds are under x squares, x to the thirds are under x to the thirds, x's to x's, and constants to constants. All right. So what if you have a polygon, okay, a closed figure, and they ask you what is the perimeter? Perimeter just simply means you're adding all the sides together. So again, you will add all the x squares together, you will add all the x's together, and then you will add all the constants together. Okay, so what I would do is just line them all up again. 4x squared minus x plus 10. And if you only want to do, the first two and then do the second one, you can definitely do that. So let's say I did these two first. Okay, I took these and I added these two together first. So that's going to give me 6x squared plus what? 4x. And this will give me plus 7. Okay, then I'll take the last one here and put minus x squared plus 11x plus 8. So that'll give me 5x squared plus 15x plus 15. So again, it's just adding all of the terms together, making sure you line up like terms. All right. For this particular problem, when it has these little dashes on it like this, it just simply means both of these are the same side. So if we're going to skip it, but I just want you to fill this in because we just did one very similar to this. So that means those sides are equal when they have the same two number of dashes, and these two sides are equal. So you would do the same thing again, add up all the sides to get the perimeter. Okay. All right, so let's go to subtraction. Subtraction, you have to be very careful. So what we just did was addition. So we just added, but when there's a minus sign here, it really changes the sign of everything inside of here. So basically they tell you to rewrite it as an addition problem. So if I do that, then it will become 7x plus 10, change this to a negative 3x, and change this to a positive 8. So once you do that, then you just follow the same process we just did for addition. Add your x's together, you have what, 4x, and then add your constants, you have 18. So the thing with that subtraction sign, it really changes, you know, you're distributing that negative to everything inside, so it changes the sign. So you've got to remember that. Okay, it's very easy to forget that. So it's best to just take care of it at the beginning and just go ahead and change it to an addition problem. All right, here's another one. So if we rewrite this as addition, we'll simply have a positive 2x and a negative 5. And then you do the same process. Combine your x's together, you get negative 12. Combine your constants together, you get negative 2. Okay, so just rewrite it as an addition problem by distributing out that negative. Okay, because a lot of students, you know, if they don't, they'll get this wrong because they forgot it's subtraction and it changes the sign. All right, same thing here. Okay, just more of the same. So if we rewrite it, this becomes a negative 2, that becomes a positive 9, and positive 2x, and then a positive 9. Okay, so rewrite it, take care, get rid of that negative, change it to a plus, and then combine your x squares to your x squareds, your x's to your x's, and your constants to your constants. Okay, so that's the big thing about subtraction. All right, we're going to move on. We're going to skip that one and move on to number 5. All right. So in number 5, we have to go through that whole process of distributing first. So let's go ahead and distribute. So this will give us negative 14x to the 4th minus 21x to the 3rd minus 7x plus 7. Right. Now, you can keep going straight across if you want and say, okay, well, negative 5 times a negative 3. What's the negative times the negative? So that's going to give me positive 15x to the 3rd. Then I'm going to multiply negative 5 times the positive 4. That's going to give me minus 20x to the 2nd. Negative 5 times a positive 8 will give me negative 40x. And then the negative times the negative will give me a positive 30. So if you want to do it horizontally, this is the way it will look. And then what you can do is say, okay, you always start with your highest exponent in the problem. So when you're ready to write your final answer, this exponent x to the 4th has to be the first one. Okay, because that's the highest exponent in the problem. I don't have any more x to the 4th, so that's going to be my first term. Okay, so I've taken care of that. And I'm going to kind of cross them out as I go to make sure I have taken care of everything. And then you go in what we call descending order. So that means if you started out with x to the 4th, your next exponent you should be looking at will be the x to the 3rds. Okay, so I have negative 21 here. I have positive 15 here for my x to the 3rds. So that's going to give me negative what? Negative 6x to the 3rd. So I'm going to go ahead and cross those out. So what would be the next term I look at? So 4, 3, 2. Very good. So it looks like I only have one term with x squared. That's this one right here. So I'm going to go ahead and just simply say minus 20x to the 2nd. So I've taken care of that. Now we're going to do the x to the 1st. And again, you got to go in that order. You just can't like start wherever you like. So we're going to now take this negative 7x's and negative 40x's. That gives me a negative what? Negative 47x. Very good. So I've taken care of those. And so now I have my constants left. So constants are always last because they don't have variables. So 30 plus 7 will give us what? 37. 37. And that's your final answer. Okay. It's a long process, but it's not a hard process. I mean, because we already know how to distribute and we already know how to combine like terms, right? Okay, so here, what they want you to do is they tell you the perimeter and you have to figure out what this side equals to. So they tell you the total should be 29x plus 5. So what do you think you would do? Yes. Very good. So you will add all these together. Okay, take that and subtract it from the 29x plus 5 and see what's left. So I'm going to give you time to do that. All right, so here's the process. So first what I did was I added the three sides together and I got 23x plus 7. Okay, then I said, okay, I got to subtract that from the 29x plus 5. Okay, but remember, this changes to a negative 23 and this changes to a negative 7. So when you combine your x's, you get 6, and your y's, you got negative 1. Yes. I mean, your constants. Thank you. All right, so we made that correction right here and right here. Okay. All right, so your final answer again would be the 6x minus 1. All right. Okay, so that's the end for that for simply.